Alright, this is Mark Anderson for Kellogg Community College, looking to give you a little help on the final exam review, and we're looking at part 5 or page 5, and this is a story problem that deals with 3 variables and 3 unknowns. It says here that Chick-fil-A has recently sold lemonades for $1.29, medium lemonades small for $1.29, medium for $1.49, and large for $1.85. During a lunchtime rush, Chris sold 40 lemonades for a total of $59.40. The number of small and large drinks combined was 10 fewer than the number of medium drinks, so how many of each size was sold? Well, what this is going to make is 3 different equations with an x, y, and z. So let's call the small lemonades x, the medium lemonades y, and the large lemonades z. So there's our x, y, and z. Now, it says here that Chick-fil-A sold them at these prices, so that's $1.29 for every small, and then $1.49 for every medium. Oops, let me change that. And then $1.85 for every large. And that equaled a total during that lunchtime rush of $59.40. So what we need to do is figure out the correct number of smalls, mediums, and larges to make that $59.40. It says Chris sold 40 lemonades during that rush, so we do know that x plus y plus z is equal to 40. Well, this gives us 2 equations but 3 unknowns, so we need another equation, and it starts right here. It says the number of small and large drinks combined, so the small and large, so x plus z, equals 10 fewer than the number of medium drinks. 10 fewer than the number of medium drinks. So how we're going to write that is y minus 10. So again, just to kind of really hammer this out here, the number of small and large drinks combined, so that's y plus z, was 10 fewer than the number of medium drinks. So these two were 10 fewer than that, and so what this is going to give us here is our equation. Now, we should push that y to the other side here, which we're definitely going to do. So we have x minus y plus z is equal to 10. Alright, so with that in mind, what we are going to do is now solve for 3 equations, 3 unknowns. And the equations we're going to look at, oh shoot, the equations we're going to look at are x plus y plus z equals 40. We're also going to look at x minus y plus z equals negative 10. And finally, $1.29 x plus $1.49y plus $1.85 z is equal to $59.40. So we're going to combine 2 of these equations together, eliminate a letter, and then we will then, have 2 equations with just 2 letters left, and we can eliminate a letter after that. Well, you can see right away that the equation I would go after, or the letter I would go after, is y, because they're already opposites. If I stack these 2 up on top of each other and add them up, x and x make a total of 2x. The y simplify to 0. The z and z makes a total of 2z. And the 40 and the negative 10 make a total of 30. Now what I'm going to have to do is pick an equation, either the top and bottom or the middle and bottom. So I'm going to choose this middle and bottom. And I'm going to multiply everything by $1.49. So here's $1.49x minus $1.49y plus $1.49z is equal to negative 10 times $1.49, which is negative $14. Hold on a second here. Negative $14.90. Now I'm combining that with this third equation, so I'm really looking at just these 2 equations right here. I'm looking at these 2, and I'm going to add these up, and what I get here is $1.29 and $1.49, and checking my work here, is going to be $2.78 x. These y's simplify. Now I have a dollar, excuse me here, I got $1.85, excuse me, $1.85, can't type on the calc right now, and $1.49, which gives me a total of $3.34 z. I'm going to add these together, $59.40 minus $14.90 gives me $44.50. Alright, so now I've got my equation in terms of x and z. So what I'm going to do is put these two together. Now since I don't really want to spend a lot of mental energy to do this here, I'm going to pick to eliminate my x's. I'm going to multiply this first line by negative $2.78. Now let me explain why I'm going to do that. If I multiply the bottom line by 2, then what I'm going to have is I'm going to have opposite values of x that will simplify to 0, leaving me with what my z is going to be. So if I look at this, I'm going to take my 2 and multiply it by negative $2.78, which gives me negative 556x. And that's also going to give me, multiplying the 2 by this, is going to give me negative $5.56z. And 30 times negative $2.78 is negative $83.04. Or 40 cents, excuse me. Okay, so now I'm looking down below. I'm going to multiply my $2.78 times 2, which is $5.56 x. Now I'm going to multiply my $3.34 times 2, and that's going to give me my $6.68 z, and my $44.50, multiply that by 2, and that gives me a solid $89. If I add these two equations together, the x's simplify. $6.68 and a negative $5.56 adds up to $1.12 z. Subtracting or putting these two together, the $89 and the $83.40 being negative, gives me $5.60. If I divide everything by $1.12, my hope is that this turns out to be a whole number, because I can't, well, positive whole number, because I can't have negative cups, nor can I have decimal cups. So 560 divided by 112, my z is 5. So now I have figured out I have sold 5 large cups. Now I'm going to take that 5 and plug it back into this one of these equations up here, and the equation I'm going to choose to plug it into is going to be this equation. I'm going to choose that equation because my x's and my z's are pretty normal numbers. They're not weird like the ones over here. So I'm going to go and write over here 2x plus 2 times 5, which is 10, is equal to 30. If I subtract the 10, my 2x is equal to 20. Therefore, my x is equal to 10. So I have 10 small and 5 large. Now, if I sold a total of 40 drinks, then it's pretty easy to figure out the missing number. 10 small, 5 large, y would have to be 25 for all three numbers to equal 40. So I have 10 small, 25 medium, and 5 large. I could write it this way because of x, y, z. I could also write out like their sizes as well. Okay, so let's go and do some work here in Chapter 4 with absolute values. I strongly recommend that you go right into the next video, because problem number 19 and the ones right after it are all kind of interlocking with the inequalities and the absolute values. But what we have to do in an absolute value problem, since the absolute value is the distance of 0, distance from 0, and there's no negative absolute value answers, you have to solve two equations. You solve the first equation like you see it, and then what you do is you solve another equation equal to the opposite answer. And we would flip the symbol, but in an equal sign problem, the symbol is actually already flipped. Well, it looks the same flipped as it does normal. So move the 2 to the other side, x is equal to 8. Move the 2 to the other side by adding 2 to both sides, x is equal to negative 4. So my answer in this problem is the finite set of negative 4 and 8. You can also write it as x equals negative 4 or, not and, or x equals 8. Also putting a comma between the two is going to work just fine. Alright, let's move this down a little bit here. Oh, we can see everything. Okay, so in this problem here, we have two absolute values. So you're probably wondering, well, how many times do I have to write the problem? And the answer is twice. You have to write the problem once, like you see it, and then you have to write it a second time with the opposite of one of the two sides. So in this case, I'm going to choose negative x minus 6. And again, flipping the symbol, but it's an equal sign, so it's pretty much, the same. We're going to solve for both of these equations. So we're going to move x to the left, and which gives me 2x plus 5 is equal to negative 6. Subtract 5 from both sides. 2x is equal to negative 11. Divide both sides by 2. X is equal to negative 11 halves. Now over here I need to distribute the negative. So 3x plus 5 is equal to negative 6 plus 6. Moving the x over here, this gives me, by adding an x to both sides, I get an answer of 4x plus 5 equals 6. Subtracting 5 from both sides, 4x is equal to 1. Dividing both sides by 4, I get x equals 1/4. So I have two answers again. I have negative 11 halves, or 5 1/2, and 1/4. You can write this in the set notation, or you can write it as x equals negative 11 halves, or x equals 1/4. Now, normally I would say in problem 19 you write the problem twice, but this is impossible, and the reason why it's impossible is the absolute value of any number will always be greater than 0 or equal to 0. So it is impossible for a to ever be less than or equal to negative 1 after you take the absolute value. So number 19 is no solution. And if you're wondering why this is no solution, if you actually solve the problem, you would be asking for a number to be both lower than a negative and higher than a positive at the same time, which is impossible. You can't have an AND statement which needs both conditions met at the same time. So doing the problem out longhand is not going to get you points because the absolute value of any number is greater than or equal to 0, so this is an impossibility. And again, I strongly recommend that you watch the next video covering problems 20, 21, and beyond, because this idea of absolute values and inequalities, it's very important that you see that and don't just leave it at this problem. All right, well, thank you for watching.